this video we'll be seeing the type of or the strategy of data reduction, that is by using data discretization. Now what is discretization? It comes from the term discrete. Discrete means different separated points. So what in this technique or what this all methods does is it just takes the data, it separates into different forms or different values, and then it tries to reduce that particular data set. So let's look all these 6 different strategies or steps in data discretization. So we start with the very first one, that is we have the binning. So this we have already studied in our data cleaning technique. Like it's a top-down splitting technique based on the number of bins which it has. So it calculates by basis of n by d, that is the number of items divided by the total bin depth which it has. And then you have certain smoothing techniques in as like binning by means, medians as well as boundaries. Well, that was easy. So let's move on to the second one, that is the histogram analysis. This also we have studied. So it's an unsupervised discretization technique. Unsupervised means it does not use any kind of previous information, and so it does not use any class information in this kind of technique, and it disjoins its ranges based upon different buckets, and so it's created for this kind of techniques, and a particular graph or a kind of layout is plotted for this kind of technique, and then you do the analysis based on that. Next you have the entropy based discretization. So it uses the concept of information gain. It is a supervised top down splitting, so it uses some kind of information. Since it uses the information gain, it has to be supervised technique, and it's a top down splitting, and there are two kinds of formulas for tuples as well as for classes. For tuples it goes in this way, like you have the information AD. So this is how the information gain is represented. So it's like the entropy which you have, D is the entropy, and you have the d1 upon d, that is mod of d1 upon mod d. You have entropy that is calculated for d1 plus d2 by d, that is mod, and then you have entropy of d2. So this technique is used for classes. This technique is used for tuples, and then for classes you have entropy of d1 which is equal to minus summation of I runs from 1 to m pi log to the base 2 of pi. So pi is that particular class intervals which you have. I ranges from 1, 2, 3, 4 up till any particular integer. So it's basically a smallest integer in that particular class. Next you have the fourth type of data discretization technique, that is the interval merging by chi-square analysis. So I've already discussed the chi-square technique in this video for data mining. So chi-square analysis technique is called as a chi-merge. So chi-merge is basically chi-square based discretization method. It is a bottom-up approach. So all these were top-down approach. This is a bottom-up approach by finding the best neighboring intervals. So it has its expected value, observed value, and then it merges these to form a longest integer or intervals recursively. Next you have the cluster analysis. So it uses some kind of clustering algorithm, agglomerative clustering and all, and can be applied to discretize as a numerical attribute. Then it can either follow a top-down splitting approach strategy or a bottom-up merging strategy. Both of it can fit. Next we come to the discretization by using the intuitive partitioning. So it basically uses 3, 4, 5 rule to segment the numerical data. So the partitioning goes in this way, like you have rule 1, rule 2, rule 3. So all these 3 rules are based on this 3, 4, 5 rule. So what rule 1 says, if an interval covers, that is these many digits like 3, 6, 7 or 9 distinct values at the MSD. MSD is the most significant digit in that particular value you have. Then you have to partition onto a range into 3 different separate intervals. If that is clear, then we move on to rule 2. If it covers 2, 4 or 8 distinct values at the most significant digit, then partition that range into 4 different equal frequency or equal width intervals. If that is clear, we move on to rule 3. If it covers 1, 5 or 10 different distinct values at the most significant digit, then partition the range into 5 equal width intervals. So data discretization by using intuitive partitioning is basically built on these 3 rules. So this you can apply in order to segregate into different partitions and different ranges. So well, that's all regarding the data discretization. We have one more technique in that, that is concept hierarchy generation. So I will discuss that in my next video. So hope you guys enjoyed this video. If you got educated by watching this video, please do like, share, comment, and most importantly, don't forget to subscribe to my channel. Thank you.